Right. This question is a question about integrating an expression that can be rewritten in terms of what are called partial fractions. Partial fractions decomposition. So the degree of the top, the degree of the numerator is less than the degree of the denominator. The degree of the top is 1, the degree of the bottom is 2. Since if you FOIL everything out, you'll have a power 2 on x in the bottom. That means we can safely state that this fraction can be rewritten as an unknown constant a over one of the terms in the denominator plus another unknown constant b over the other term in the denominator. I'm going to cross multiply, or another way to say that, I'm going to multiply everything by 2x plus 1 on both sides, and multiply everything by x plus 3 on both sides, and then cancel whatever cancels. And if I do that, I get the following. 20x is equal to a times x plus 3 plus b times 2x plus 1. This has to be true for all values of x, like 0, 1, 2, and so on. The smart thing to do next is to be strategic in choosing a value of x that's going to easily reveal the value of a. So looking at what we have here, I can make that first term disappear on the right if x is negative 3. So I'm going to choose x equals negative 3. That has to be plugged in on both sides. So negative 60 is equal to a times 0 plus b times negative 6 plus 1, so negative 5. So negative 60 is equal to negative 5 times b. And we can divide both sides by negative 5 and get b is equal to positive 12. So I've got that one. Now I'm going to make another choice. How do I get this term over here to turn into 0? I have to use a fraction. So if I set 2x minus 1, or 2x plus 1 equal to 0, rearrange, 2x is equal to negative 1, so x is equal to negative 1/2. So I'm going to choose x equals negative 1/2. And then plug that in. So I have 20 times negative 1/2 is equal to a times negative 1/2 plus 3 plus b times 0, since that value was selected to make that b term turn to 0. That's why I set 2x plus 1 equal to 0. I want to find the value of x. I would need to make that term disappear. Now there's other things we could have done. We could have set x equal to 0 and plugged in our value of b and avoided all the fractions. Or chose x is equal to 1 and plug in our value of b and avoided all the fractions. But it doesn't matter. Let's keep going with this because it's more formulaic. So negative 10 is equal to, now in that bracket on the right hand side, we're going to have to make common denominators. So 3 is the same thing as 6 over 2. So negative 10 is equal to a times positive 5 over 2. Then cross multiply by 2, so negative 20 is equal to 5a. And that means, divide both sides by 5, a is negative 20 over 5, which is negative 4. Okay, so we have our value of a. And what we do with this is we substitute in what we just found, a over 2x plus 1 plus b over x plus 3 for our values of a and b, into our integral. So this becomes the integral of the a over 2x plus 1. I'll write it down as a over 2x plus 1 plus b over x plus 3 dx, and then sub in the values that we found just now for a and b. So a we found was negative 4 over 2x plus 1. And then we have a second integral plus integral of 12 over x plus 3. I'm going to use a shortcut here to do these integrals. It's a shortcut that's in the notes. That if you take the antiderivative of 1 over a linear term, 1 over ax plus b, you'll get 1 over a times log and absolute value of ax plus b plus a constant of integration. And how that comes about is if you're using substitution with w is equal to ax plus b. So quoting that result, we'll have negative 4 times the antiderivative of 1 over 2x plus 1. So 1 over 2, 1 over a, times log and absolute value of 2x plus 1. Plus, there's a plus c, but I have another plus c from this one, plus 12 times log and absolute value of x plus 3. The constant in front of the x is just a 1, so 1 over 1 in front, I don't really need to write that. And we can simplify the first term. We get negative 2 times the log and absolute value of 2x plus 1 plus 12 log and absolute value of x plus 3 plus c.